to the different use of the hall, the requirements for sound quality are different, and the factors of sound quality design is also different, like in a hall dominated by natural sounds, the scale must be controlled to maintain sufficient volume, and earlier reflections must be arranged to improve loudness and clarity. The scale and shape of the hall, mainly based on electroacoustics, are not limited, but the reverberation sound needs to be controlled within a certain range, and the arrangement of the speaker should consider the uniform distribution of the sound field. Tall space need to prevent echoes. For small space such as recording studio and listening rooms, attention should be paid to room proportions and sound absorption arrangements. In general, indoor sound quality design should follow the following principles. The first, prevent external noise and vibration from entering the room, so that the background noise in the room is low enough. The second, make enough loudness everywhere in the room and ensure that the sound field distribution is as uniform as possible. For halls dominated by natural sounds, pay attention to choosing the appropriate scale. The third, arrange enough earlier reflections. The fourth, make the room have a reverberation time suitable for the purpose of use. The fifth, to prevent acoustic defects. The determination of the hall volume needs to consider two aspects. One is to ensure sufficient loudness, because the larger the volume, the lower the sound energy density, the lower the sound pressure level, and the lower the loudness, so the maximum allowable volume is limited. The second is to ensure proper reverberation time, because the reverberation time is proportional to the volume and inversely proportional to the sound absorption, and the proportion of the audience sound absorption in the hall is the largest. Therefore, the volume index of each seat is used. Different volumes of each seat are given for different halls, and the volume of the hall is obtained by multiplying the number of audience. In the later stage, the volume can also be adjusted through the ceiling, stage reflector, etc. Considering that the wavelength of sound waves in the audio frequency range is much smaller than the size of the hall, the geometric acoustic method can be used to describe phenomena such as sound propagation and reflection. Therefore, the sound rain method is used to design and shape of the hall. The sound line perpendicular to the wavefront represents the direction of sound propagation, obeys the law of reflection, because it propagates in the same medium. Refraction and diffraction are not considered. Interference are also not considered. Only energy addition is considered. This is an example of using the sound rain method to design the ceiling section of the auditorium. Point S is the sound source, located 2 to 3 meters behind the stage curtain line, 1.5 meters high. A, B, C, D are receiving points, 1.1 meter from the ground. Determine the first section of the ceiling from point A' outside the stage to provide the first reflexive sound for the auditorium from point A to point B. The first step, connect SA' and A'A, draw the angle bisector A'Q1 of the included angle SA'A, and draw the vertical line A'A' of the A'Q1 through the A' point. The second step, taking A'A' as the axis, make the symmetrical point as one of the sound source S, that is, the vertical sound source of S. The third step, connect S1B and A'A' intersect at A' point. The line segments A'A' is the section of the first section of the roof. The fourth step, determine the second section of the ceiling to provide the first reflection sound for the auditorium from points B to C. The starting point B' of the second section of the ceiling is set at an appropriate position on the line connecting the sound source S and the end A double prime of the first section of the ceiling. That is the extension line of SA double prime. Use the same method as in the first section to obtain the section B prime B double prime of the second section of the ceiling and the vertical sound source S2. The fifth step, obtain the third section ceiling section C prime C double prime and the vertical sound source S3 in the same way. Since the vertical sound source is used, it is also called the vertical sound source method. This method can also be used to design sidewall planes. You can use the sound ring method to try to complete the architectural design assignment to see if it matches your expected shape. Can you also think about the shortcomings of this method?